You can annotate on the screen, or you can also use a chat to answer. So the first one, because it's a neutral, so it's a neutral, so the number of proton and electrons should be same. That's right. What about the number of protons here? This is also a neutral, so it should be same. And electronic configuration, because 18 electrons you have to arrange, so 288. And what will be the net charge? So net charge will be -1 or -1, because more electrons are there than protons. Which two particles in the table give isotope? To be an isotope, they should have same number of proton but different number of neutrons. So A and B, because they have 11 protons but different number of neutrons. Next, element Z is in the same group as in the periodic table as A. So A and Z are in the same group. State the identity of element Z. How to identify element Z? Same group, but it is less reactive. For means when you check the periodic table, 11 protons means this is sodium, which is Na. So this is sodium, and for group 1, as we go down the group, the reactivity increases. They become more reactive as we go down the group. They mentioned that this is less reactive, so Z should be above sodium. So which element is above sodium? So lithium is above sodium. C is unreactive. Use and for why? So C is unreactive. Why? Because it has complete shell, complete outer shell. So complete outer shell electrons. Don't forget to mention the term outer, because the outer shell affects the reactivity of the atom. So it has a complete outer shell. That's why it will have, it will be unreactive. This question is about the masses and the volume and moles. Which term is defined by the following statement? Average mass of naturally occurring atom of an element on a scale where the carbon 12 has a mass of exactly 12 units. What we call that? The average mass of naturally, so we call that as a relative atomic mass, RAM. Butane C4H10 has a relative molecular mass of 58. Potassium fluoride has a relative formula mass of 58. Explain why the term relative formula mass can be used for butane but cannot be used for potassium. What is the reason? Because what potassium, when we say potassium fluoride is a giant structure. Like it contains potassium ion, then fluoride ion, then another potassium ion, then fluoride ion. And this structure continue. It has a giant lattice with the oppositely charged ions. So the ratio between, like ratio of the potassium to fluorine in this whole structure is 1:2. That's why Kf is actually a simplest ratio between potassium and fluorine rather than the whole molecule compound, whole mass of the molecule. So potassium fluoride, why we say it's a formula mass rather than a molecular mass? Because it shows potassium fluoride has a giant structure, which shows that the ratio between potassium and fluorine is 1:1. So all ionic compounds have a giant structure. That's why when we say NaCl, this NaCl is not showing that one sodium and one chloride. It shows the ratio between sodium and chlorine in the lattice is 1:1. And when we write 23 and 35.5, so it will be 58.5. So this 58.5 is not known as a molecular mass. Actually, it is known as the formula mass because it shows the simplest ratio of the ions which are present in the molecule. So ionic compounds, actually it's not the molecular mass. We use the term molecular mass, but actually it is a formula mass which shows the simplest ratio of the ions in the structure. Is it clear? Part A and B?